Hey everyone, good morning. My name is Ajita Patel, and I'm your Technical Service Manager for North America. Today we will be covering safe handling of aluminum. And before we start any further, I do want to let everyone know that this session is being recorded. And without further ado, I'll give Roland a couple of minutes to introduce himself and then start the presentation.
Thank you, Achita, for the starting the event. Welcome to everybody. I just want to introduce myself. My name is Roland Albert. I'm Technical Service Manager here at ECKART headquarters in Germany. And I have the pleasure to give my first webinar in my life. So this will be also challenging for me. Together with me is Alexander Wenzlik. He takes care of the chat. So whenever you have questions, please feel free to ask questions. We also will stay a little bit longer after the presentation, so you can send your questions and we try to answer direct in the chat or later to contact you and give you all the information. Yeah, maybe you wonder about this photo of the space shuttle, but this is exactly the reason why we have to talk about safe handling of aluminium powders. Because whenever aluminium starts burning, it sets free a lot of energy. And this is used for rocket engines. So for example, the boosters here at the space shuttle are the most powerful rocket engines ever been built. And they are fired with aluminium powders. And therefore, you can estimate whenever aluminium powder starts burning, it sets free a lot of energy. And we want to avoid this in our factories, of course. So the agenda is we want to see what are the hazards. On topic C2, you see it's fire and explosion. These are the hazards. Have a look on details. What are the fire and explosion characteristics of aluminium powder? And then we see what are the conclusions for storage and processing. We also have a look how personnel can protect it in case of a fire. And at last, what we want to avoid, if there is a fire, how we can fight this fire. Yeah, starting with the good news, aluminium is non-toxic, non-chronic effects are known, are proven. There had been some investigations because of Alzheimer's disease, but nothing had been proved. So aluminium is not a poison. It's also not environmental hazard because aluminium is the fourth most common element in Earth's crust. So therefore, it cannot be so much poison. And you must have in mind, whenever we send out an aluminium powder, the surface is always covered with a layer, maybe of aluminium oxide or silica. So all aluminium powders we sell are saturated. So they never starts burning on its own. It's always have got saturated surfaces. But what are the hazards of aluminium powder? You can see when you look on our drums, you will see it's as a flammable solid. Here you see a fire, how it's burning, and I want to show in a little movie how this looked like. In this case, now I have to share my screen. This movie, I want to tell you, never try this at home and never show this movie to your children. This guy you see here in the movie is one of our well-trained firefighters in our plant. And you can see we have distinguished agents around, and he also wears safety clothes. And now let's see what happens. He's smiling because he's the only guy who is allowed to smoke at our plant, because in our plant we have a general smoking is not allowed. And he's very brave, but now you see it's not so dangerous that it immediately starts burning, but please never try. It also can sometimes, when we repeat it, it also sometimes ignites quite fast. So now I have to switch back to the presentation. Sorry for this. Yeah, but what are the hazards? The being a flammable solid, it seems it's not so much dangerous. What is much more dangerous with aluminium powders is the risk of a dust explosion. So there is an explosion hazard of a combustible dust-air mixtures. What also is special with aluminium powders, whenever the aluminium powder is flowing, it can pick up so much electrical charges that these electrical charges can ignite a dust cloud. So it is the fact that the ignition source is maybe included in the property of the aluminium powders itself. There's also a risk of formating hydrogen gas whenever aluminium is in contact with water or chemicals, though this is also a risk. Usually not so much a risk in a powder coating plant. This is more a case when you work with waterborne paints. Dust explosion is really an issue and very, very dangerous. Therefore, I share my screen again to show you an example of a dust explosion. Maybe when you Google, you can find the Georgia sugar refinery explosion. And here you can see a photo how the plant looks like after an explosion. And the material which exploded here was sugar, so not a special chemistry. It's something you use daily in your kitchen, but the dust explosion can really damage a lot. This refinery explosion was very well investigated by the government, and there is also on the web information. You can find it here on the CSB homepage. This was really helpful. It's really helpful because they investigated very well the reasons for this horrible dust explosion, where some people died and many had been injured. So avoiding a dust explosion, this is really an issue when dealing with aluminium powders. So let's have a closer look to the fire and explosion characteristics of aluminium powders. Starting with the burning characteristic, as you have seen with a cigarette before, aluminium powder is in the classification class 4. So there is a classification of burning solids starting from 1 with cannot be ignited down to 6. This is the most dangerous class, and aluminium is in class 4, so somewhere in the middle. That means that it is possible to ignite, and there is a smoldering fire or slow seamless decomposition when starts burning. This is the test you've seen, how this test can be made. We do this test here in our plant, and I want to share a little video, as I know you want to see aluminium powder burning, and therefore I try to share my screen. Just maybe take a little bit time to open it. Yeah. So this is the test going on. So we ignite this layer of aluminium powder with a gas flame, and then it starts burning, not very fast, here also without smoke or less smoke. It's a very hot fire, nearly flameless fire, but as you can see, it's not exploding or not so dramatic. Now I'm going back to the presentation. Now let's have a closer look to the explosion characteristic. And if you work with powder coatings, you are used to deal with powders that can explode, because also standard powder coating is a dust explosion can be generated with powder coatings, and some numbers of the powder coatings are quite similar to aluminum powder. So, for example, the lower explosion limit, quite similar. Also, the ignition temperature is very similar to aluminum powder. The huge difference is that aluminum powder can be ignited with a lower minimum ignition energy. So it can be below 1 millijoule, and this means it's extremely low, and therefore electrostatic can ignite easily an aluminum dust cloud. Also, other pigments can be ignited as a dust cloud. For example, bronze pigments we also produce, but they are much lower, even with the explosion, with the minimum ignition energy. Yeah, let's have a look to other properties and characteristic numbers of dust explosivity of powder coating. When reducing the oxygen level down to less than 5%, for example, by diluting with nitrogen, so then it's possible to avoid a dust explosion. So below 5% of oxygen, there will be no dust explosion. The ignition temperature of a dust cloud is above 400 C, is also nothing special. It's not extremely low. But as I mentioned before, the minimum ignition energy, this is something special. Therefore, I highlighted here in pink that it can be below 1 millijoule for the finest products. But when we have an aluminum powder, even if it's not specially fine grade, there are also fine particles inside, and you never can avoid this mixing or accumulation of the finest products, and therefore we always deal with the worst case scenario of this less than 1 millijoule. Yeah, although here some further characteristics, these numbers are more difficult or takes more to find out. This is a special vessel, a large vessel where this can be tested. We cannot do this test in our plant, so we have to send it to another lab, quite expensive, time-consuming tests. But we want to provide the numbers, to share the numbers with you. The lower explosion limit of aluminum powders usually is between 30 and 60 grams per cubic meters, depending also on the particle size. Something special with aluminum is a maximum rate of pressure rise. That means how fast is the overpressure increasing in kind of an explosion. And this is with aluminum powders extremely high, up to 1,100 meters per second. From this number, the KSD value, which is the base of the dust explosion class, comes from. There are 3 dust explosion classes, 1, 2, 3. So ST3 is the highest class, and the highest class is starting at 300 bars meter per second. And you can see aluminum goes up to 1,100 meters per second. So it's in the highest class, and within this class, it's on the top end. That means it's a strong dust explosion possible with aluminum powders. Also special, the maximum explosion overpressure can be up to 12.5 bars. That means when you do a construction of a vessel, you can make an explosion-proof vessel, but to make a vessel with last 12.5 bars is extremely difficult to design. So these are the special critical numbers here of aluminum powders. Yeah, and I'm quite sure you want to see a dust explosion. So therefore, I looked on YouTube and I found a dust explosion. So therefore, I try to share my screen again to show you this little video. So it's quite fast, very fast explosion. So therefore, now in slow motion, and you see first the dust cloud, and now immediately the bang with a huge explosion. Okay, let's go back to the presentation. Yeah, what are the conclusions? Now we have got the numbers, we know the hazards, we have got the exact numbers. What are the conclusions for storage and processing? You must have in mind to get a fire or dust explosion, you always need three things at the same time. A flammable material or dust cloud, an ignition source, air or oxygen. And so sounds quite simple to avoid a fire or a dust explosion. We have to avoid any conditions that have a dust cloud, or we have to keep ignition sources away, or we protect powder from oxidants under inert conditions. So whenever handling aluminum powder by hand, so we need oxygen for the worker, so we cannot avoid this. So whenever we're handling manual powders, avoid a dust cloud and or keep ignition sources away. Whenever we process in a closed system, we can generate inert conditions with nitrogen and then have also a good control on the explosion risk. So for the manual handling where we cannot avoid the oxygen, so we recommend, or it's also our experience, of course, keeping containers sealed, use only small portions. So this help in case of a fire or accident, you have less explosives or flammable material around, and there you can limit it to a small thing. Here you can see a photo. This is a room we have got in our bonding facility. Here we designed the whole process. We have only one room where it's allowed to handle aluminum powders. And in this room, we have got all the safety issues. And here we fill in manually, weighing into little containers, seal the containers in this room, and then bring the closed containers to the mixers. We can dock them on the mixers, and then we have got the aluminum in a closed system with nitrogen inertization. So this limits the risk of an aluminum dust explosion only to this little room where we're handling the open aluminum powder. And this is a good design to reduce the risk of aluminum powder. So whenever handling these smaller portions with grounded shovels, make sure using only conductive tools and containers, no plastic bags or plastic tools because of the risk of electrostatic charging. And as I mentioned, yeah, install closed aluminum transfer procedures wherever it's possible. This is really helpful. Also, this is mention the training of the people to work thoroughly and exactly to prevent dust clouds. It's really a thing of a personal behavior, how to handle and how to work. It's very important to work in here without generating dust clouds. Also very important, do not use any vacuum cleaners when spill some aluminum powder. Standard industrial vacuum cleaners are not designed for you working with aluminum powder. So only a few special vacuum cleaners are available. So standard vacuum cleaners are not designed for using with aluminum powder. For example, in our plant, we do not have any vacuum system in this area where aluminum powder is handled manually. So whenever there is a spill of aluminum powder, pick up dry mechanical by using natural brushes and conductive shovels. One important thing is a good housekeeping practices when handling with aluminum powders, because you will not completely avoid any dust layers somewhere. So it's important to keep the area quite clean. And I also found on the web again a good movie of the Aluminium Association in the US. And I like these videos a lot. So I recommend to use them also for training of your personnel. So therefore I share it here, how they explain this housekeeping issue.
A comprehensive and effective housekeeping program is essential to the safe handling of aluminum powders and pastes. Good housekeeping practices must be maintained in all areas of your facility where aluminum powder and paste are stored and handled. Spills of aluminum powder or paste should be thoroughly cleaned immediately. Excessive accumulations of fugitive aluminum dust create the potential for catastrophic secondary explosions should a fire or explosion take place at the facility. Guard against the accumulation of fugitive aluminum dust on processing equipment, floors, walls, piping, ductwork, and other surfaces. Special attention should be paid to elevated areas, such as exposed building structural members, support beams, and elevated platforms. Areas above suspended ceilings should be inspected regularly to avoid the buildup of fugitive aluminum dust. The interior of ducting used in the transport of aluminum powder or dust should be inspected and cleaned regularly to avoid the buildup of excessive dust on inside surfaces. Cleanup of aluminum powder and dust should be accomplished by the use of soft, natural fiber brushes, brooms, or squeegees with non-sparking conductive scoops or dustpans to pick up the collected material. Care should be taken to avoid excessive airborne dust during cleaning activities. Synthetic fiber bristle brushes, plastic, or other non-conductive scoops should not be used since they tend to accumulate strong static charges. Standard industrial vacuum cleaners must not be used for the cleanup of aluminum powder or paste. Only specialized custom machines specifically approved for use with combustible metal dusts can be used for these housekeeping activities.
Yeah, I'm coming to the next topic, to avoid sources of ignition. So the next possibility to avoid a fire or dust explosion. This usually is my experience. This is usually quite well done at powder coating manufacturers. So using, of course, only X-proof mechanical equipment. Also have in mind flashlights and portable power tools. So also electrical equipment, of course, has to be according to the electrical codes. Very important, enforcing a no smoking rule. For example, at our plant, it's the whole plant is not allowed to smoke, only a few rooms where it's allowed. It's also helpful not to allow to have got the lighters and the thing with you in these areas, because then there's no risk that light up the cigarette by mistake. Yeah, so very important to avoid this. It was mentioned also in the housekeeping video that also have in mind that friction sparks can ignite an aluminum dust cloud. So therefore, avoid metal to metal or metal to concrete contact, especially if it's rusted steel or rusted iron. So therefore, we recommend to use aluminum shovels, and for example, here a hammer made from wood or brass, or for cleaning these brushes with natural, made from natural materials. Have also in mind, in case of contractor is coming in or you have to maintenance issue, use um, these sparks can be created by welding or cutting. So to install a hot work permit system is strongly recommended. Also, a mixer can be a source of ignition, especially high-speed mixers. So a hot shaft, a hot seal can ignite easily your mixture. This cannot happen, or not so easy happen, with a dumbbell mixers. So for high-speed mixers, we recommend always some inertization with nitrogen. And at last but not at least, and this is the experience what we have been reported of accidents in powder coating industry with aluminum powders. The accidents I know about, always a plastic bag was involved. So handling pure aluminum, we strictly recommend not to use any plastic bags or containers at all, even if they are labeled as anti-static. It's still possible to generate this minimum ignition energy of less than 1 millijoule. And also, even you cannot ground well a plastic bag. Yeah? A metal container, it's easy to put a clamp on it and ground it, but how to ground a plastic bag? Therefore, do not use any plastic tools, shovels, or any plastic bags for filling aluminum powders. This is very, very important. Of course, all equipment, pipes, and so has to be grounded to avoid pick up this electrostatic charge. Yeah, also persons can pick up electrostatic charge. So shoes, sport shoes are not the correct shoes for when handling aluminum powders. And also movable equipment has to be grounded. Here you can see a photo from our weighing room. So the drum and also the small container, everything is grounded. So ensuring the grounding chain by the feet, the shoes, and grounding the containers. Yeah, I mentioned it before, for mixers, but also for other closed equipment, it's possible to use inert conditions. That's usually for bonding machines. That's usually state of the art to control the oxygen level by inertization with nitrogen. Yeah, let's have a next how we can protect personnel in case of a fire or explosion. We recommend this fire-resistant work clothing. It's a European and German industrial standard where that people should wear this. Feet protection, working shoes, all standard working shoes are conductive. So therefore, whenever a working shoe is used, the risk of electrostatic charge picking up is dramatically reduced. Yeah, respiratory protection. We learned aluminum is not so a risk for health, but dust in general shouldn't come into the lung. Though therefore these FFP2 masks are required. After 2 years of COVID, everybody knows the mask, unfortunately. So this is also recommended when handling aluminum powders. The protection of hands. We have got some recommendation that not only to keep the hands clean, it's also in case of a fire. And this safe face protection I will show in details with the next page. We recommend this type of natural leather gloves with a long shaft. The advantage here is to the standard gloves. The standard gloves are not long enough. So whenever you stretch your arm, here a part of the arm is not protected in case of a little flame or fire. And these standard working gloves have got, on the backside, they have cotton. And here in the cotton, aluminum can accumulate. In case of the fire, it starts burning here and burn your hands. These natural leather gloves are much better here. And the natural leather has also the advantage, whenever you start a little bit of sweating, these natural leather became conductive and can help to ground your tools you have got in your hand. We have also very good experience here with these face shield. This face shield is made of a metal mesh, so it's not a plastic or a glass. It's a metal mesh. The advantage is it does not go blind whenever aluminum becomes there, and these mesh protect really from a fire. Some years ago, we had an accident where there was a little fire in a machine and a flame came out from the machine. And in this moment, a worker was standing here and he had this shield here and he had only a little bit of burning here in the neck, which was not protected, but the whole face was completely protected. So in the case, if he wouldn't wear this face shield, his whole face would be burned, but these metal mesh protected his face completely. And it's a quite simple thing, and it does not go blind whenever it's covered with aluminum. Yeah, firefighting measures. So yes, in case there is a fire, we want to give you some guidelines, but I do not want to do on my own. I will also forward you to the aluminum organization in the US. They have got also a good movie there showing how to firefight metal fires. And I want to share with you, and you can use this video. I will show you the link at the end of the presentation. You can show this movie also for training your personnel.
Since it is almost impossible to extinguish an active dry aluminum powder fire, solutions to the problem are focused on the control of these fires in the incipient stage. Aluminum powder fires are characterized by the emission of extremely bright light, very high heat, and the generation of large amounts of white smoke. Suppressing a metal powder fire should only be attempted by personnel who are trained in the special precautions required for fighting fires involving such combustible metals. In the interest of life safety, an assessment of the situation should be undertaken to determine if the fire can be safely fought with existing resources. It may be that the most prudent course of action would be to isolate the fire as much as possible and allow it to burn itself out. Professional or volunteer firefighters from the surrounding area cannot be expected to be trained for the specific fire and life hazards associated with aluminum powder and paste fires. Local firefighters, however, should be directed by the facility safety personnel for their own safety. Water must never be used to fight an aluminum powder or paste fire, since the water will react with hot aluminum powder to form highly explosive hydrogen gas. The force of the water hose stream may also suspend the aluminum powder and form a potentially explosive dust cloud. Fire extinguishers rated for Class A, B, or C fires also must not be used, since the extinguishing agent may react with the burning aluminum powder and instantaneously accelerate the fire. Halogenated extinguishing agents are also not used on aluminum powder or paste fires. If such extinguishers are present in an area where aluminum powder or paste is handled, they must be marked not for use on aluminum powder fires. Aluminum powder fires on reasonably flat surfaces may be controlled and isolated by blanketing the burning material with a Class D type dry extinguishing agent and then by wringing the burning material with dry sand. Long-handled shovels or scoops made of non-sparking material are to be used for the application of dry extinguishing agents. This should be done with great care to avoid disturbing the powder and forming a dust cloud, as even a minor dust cloud may explode violently. A properly blanketed fire will develop a hard crust of metal oxide, which ultimately eliminates enough oxygen to cause the fire to self-extinguish. After dispensing the extinguishing material, all personnel should leave the area, closing all doors which lead to the area, and then sealing them with sand or other dry granular non-combustible material. All fans and machinery, including dust collection systems, should be completely shut down. Drafts should be eliminated wherever possible. The aluminum powder may continue to burn under the crust without visible flames and therefore should not be disturbed until such time as it can be determined that the fire is completely out. Disturbing the crust may cause reignition of the fire. Flake aluminum powder has a lower density and a much greater surface area than atomized aluminum powder. Therefore, it tends to not only disperse and form dust clouds more easily, but also ignites more readily. Great care must be taken when attempting to extinguish a mass of burning flake powder so that the particles are disturbed as little as possible. Aluminum paste products consist of aluminum flake powders suspended in a high flash point combustible solvent. An aluminum paste fire typically begins as a solvent fire and can be fought using Class B extinguishing agents such as dry chemical, foam, or carbon dioxide. Once the solvent fire is extinguished, the residual powder may reignite due to localized heat or spontaneous heating. To avoid reignition, the residual material should be smothered with a Class D agent. At some point, the paste fire may begin to exhibit the characteristics of a powder fire, at which time it must be treated as such. Obviously, judgment must be used in determining whether Class B agents can be safely used on aluminum paste fires. If the Class B agent is applied carefully, it will be very evident if the fire is accelerated. At this point, the fire is considered to be a powder fire, and the use of Class B extinguishing agent should be discontinued, and a Class D agent, or dry inert granular material such as sand, used in the manner indicated for an aluminum powder fire.
Yeah, so the firefighting is what we want to avoid by handling the aluminium in a safe way. And here I'm at the end of my presentation. Detailed information you can get of the Aluminium Association at their homepage, at our ECKART homepage under markets powder coatings. We have got also safety instruction of the German Aluminium Industry Associations. You can download that from here. Or if you need further information, of course, you can contact Archita or me and getting some information. We will stay here in this room for another few minutes. So whenever you have got questions, please ask them in the chat, and we try to answer them immediately, or my colleagues Alexander will answer them, or we contact you later. We will send you also a link to download this presentation and with the relating videos. So please feel free to contact us for further information. Thank you for your attention, and always safe working with our aluminum powders. Thank you.
Thanks, everyone. Are there any questions so far?